So I sort of like, give another example with the business model in this case.
This meeting is being recorded.
So for this particular problem, it's telling you that TBC has a factory in Myanmar. Suppose that he estimate the cost in jets of operating X item is given by this function. C of X is equal to 15,000 minus 0.006 x to the second power plus 0.01 x to the third power. So now the first question is asking you, find the derivative of the cost function evaluating at 120th item producing. What is that value? And then also interpret it, what does that mean? So to do this problem, part A, when we look for the derivatives of the functions, derivative of a constant is 0 minus 0.012. When you take derivatives, you bring down the power and then multiply it out, and then minus 1 to the power, and then plus, and the last part is bring down the power, so 0.03 x to the second power. So simplifying a little bit, that gives us 0.03 x to the second power minus 0.012 x. Now what we want to do is we want to find out the derivative of this function evaluating at 120. So that's basically 0.03, right, to the 0.03 times 120 to the second power minus 0.012 times 120. So when you use a calculator to compute this, that will give me 430.56. And this is in jet, so KYAT. So that's the currency of the Burma. So finding the derivatives is easy. Evaluating the derivative is also easy. Now, the interpretation part, what does that mean? Okay. So this C prime of X, the derivative of the cost function, that's basically talking about, the instantaneous rate of change on the cost. And very soon, I'm going to help you to define, in business terms, this is called the marginal cost, right? We're going to define that very soon later on. So more interestingly, right now, what we are interested in is how to interpret that C primes of 120. So what does that mean, C primes of 120? That is basically talking about the rate of the cost is increasing. And I'm saying increasing because the value of C prime is a positive, so I'm talking about increasing. So the cost is increasing at a rate of $430.56 on the productions of 120th item. So we are talking about a particular production case, right? So the C primes of 120 basically interprets the rate at which the cost is increasing as the 120th item is producing. So that's what it means. So we are talking about instantaneous rate of change at that particular production case. Any questions before I move any further? All right. So now part B is basically asking you to, compare what we found out in part A with, right, the cost of producing 121st item. So if we are producing one more item, what is going to be the cost? So that basically means, RB, that basically means I need to find out the the cost of 121st item minus the cost of 120th item. So from 20th item to producing 121st item, what is the change in the cost, right? So that would tells me how much it's going to be cost. So this basically tell us putting this 121st into this cost functions using calculator to compute it, right? And making sure that on a calculator you don't need to punch it in over and over again. You can just recall it, right, from what you already punched in. Make sure you know how to do that. So that will help you to speed it up. So when I plug it into the functions, right, the cost functions for 121, this is the value that I got: 32, 62, 7.764. Minus when I plug it in 120 into the cost functions, this gives me 32, 19, 3.6. And when I subtract these two, that gives me 434.14. Check. So now that we computed already, right? So this is basically the cost of producing 121st item, which is basically like from 20th item to 21st item, how much do we, cost more? So you can see that it costs what? $434.14 jets more. Right? Now, this value, we sort of know that it will be around there from part A, because part A is already telling you that when you are producing 120th item, right, the rate of change on the cost is increasing approximately 430 and 56 jet. So you can see that these two values are very close to each other. Okay. So before I conclude this, I'm going to sort of give you a visualized picture idea so that will lead us, why the next session that we're going to talk about is important. So basically, we're going to do the approximations, right? So if you look at on this picturized idea right here, this is like, let's say this is my cost function, right? C of x. So right here, this is where we are producing 120th item. And right here, we are producing 121st item. So, these two values, right, when we talk about the change in y, right, cost of 121st minus cost of 120th, the change in these y value so the change in this y value, which is C of 121st minus C of 120, right? That is basically the change in y value, right? The change in the cost. And how much is being produced, how much is the change, that basically we can already see that it's very close to what the slope of the tangent line, which is the instantaneous rate of change, right, at this part right here, this point right here, C primes of 120. So we know that these two values are very close. So later on, we're going to talk about this derivatives and then, how to approximate for the function value in 2.9, which we're going to talk about approximations.
The recording has stopped.
Any questions before I move on?
So just to be clear, the part A was finding the slope of the tangent, C prime of 120. And
in this case, you are not interpreting as the slope of tangent anymore. Okay? You're going to be interpreting as according to this function. you are right. The first derivative is basically talking about the slope of the tangent line on a curve. When the curve has no meaning to it, meaning it's like it doesn't apply to any application problem. But when it starts applying to application problem, then you cannot just really say that it's slope of the tangent line. So it becomes the rate of change for that particular problem.
So is A trying to estimate what B is giving me exactly?
What I'm trying to point out right now is like, how close the value of A, right, and then B's are.
Okay.
But we need to talk about more in order to talk about approximations. Just the derivative alone would not help you to see the approximations of the function, the change in the function value. Okay. But what I'm trying to point out right here is like, the rate of change on a part A sort of give us an idea from, on a part B. Right? So producing like from 120 to 121st item, what is the cost gonna be? Right? Because the rate of change on 120th item on the cost part is already telling me that it's increasing around like $430.56. $430.56 already, right? So we can expect that much right there. And of course, like we will talk about later on like maximums and minimums. So that could also like go back down after a certain point. Right? But anyway, that's basically what it means so far. Any other questions? Okay. So to finish up this, okay.
This meeting is being recorded.
So like I pointed out before, now I'm gonna tell you what actually this means. Right? The marginal cost this term is used in business for this particular situations. Limit as delta x approaches to 0 of change in the cost functions divided by change in the numbers of items that you are producing, which basically this is the definitions of derivatives, which tell us the C primes of x. Right? So when we talk about the rates of the cost is changing, right? Instantaneous rate of cost changing is basically called the marginal cost in a business term. So to be more precisely talking about it, right? So the marginal cost is the instantaneous rate of change of cost with respect to the number of items produced. So that's basically what we are talking about. It's good.
The recording has stopped.
So that's the last, terminology that I want to put it in before we end this session. So this session is more about like, interpretations and understanding the usage of this derivatives operator that we learned it, right, with a different applications problem. Any questions? All right. If you don't have any questions, then take about like 6-minute break, and then we're gonna go into 2.9, which is near approximations.